All right. Looks like we're live. So, we'll just wait for some people to show up. What are we going to do? Oh, looks like I'm a little laggy. Hold on. All right. I guess it's not that bad. Oh, no, it's pretty bad. That was another sip of coffee. All right. Well, I guess we will at least get started with some little talkie. I'm going to try really hard not to rush through this. I had a very, very cool conversation before this. Got a huge bomb dropped on me. It was like Christmas for me. Like everything I wanted to do, like our principal engineer or whatever was saying that I get to use a piece of technology I didn't that I've wanted to use for like a year now, haven't been able to use, and I might get the chance to work with one of my favorite engineers. So I don't know, it was pretty crazy. And then my little thing that I like to do is just talk people out of it for some reason. Man, I am so excited right now. So I hope that I don't rush through this in my excitement. But what we're going to be doing is going over logic functions. So we played a little bit with combinators and point-free functions and stuff last time. So I guess the next logical thing to do is to kind of use predicates to and different logic functions to see and kind of build our chops in putting together, I don't know, predicate functions. Different predicates and stuff like that. So I don't know. I like them. They're fun. And we'll do a little bit of contrast with Ramda because there's some differences between crocks and Ramda. We have kind of the same functions, but just little differences here and there. So I'll just point those out as we go through them. But I guess the first thing we're going to start off with is kind of just looking at what I mean by these. Well, I guess first we can look at what a predicate is, right? So in Crocs, we have all of these predicate functions that ship with it, like prop equals, I don't know, has prop path, is an integer, is a monad, like all of these little things. But one of the things you'll notice, what makes it a predicate, and for the most part, what makes it a predicate is it goes from some A to a Boolean. I wonder, oh yeah, that's supposed to be like that. I don't like that. I think I'll change that. So we basically have a function that goes from something to a Boolean, and that's what makes it a predicate function, right? We use all of these, and we use a lot of predicates. Like if you're like me and build a lot of like enterprise-y apps, things like that for companies, then you tend to get all this business logic and all of this stuff, these things you need to validate that are specific for your app. And so you end up writing your own predicates, this, that, and the other. So Ramda and also Crocs provide a lot of these logic functions that kind of help you build that logic easier, I guess, in a more declarative way. So we're going to play with these today. And I guess the first thing we should start off with is making something a predicate, or actually like making a predicate. So what I'm going to do is I'm going to provide imperative examples, and I'm also going to show what a declarative. We're going to get to a point though, and I just want to stress this. A lot of times I get asked, could I see how you would do that in an imperative versus a declarative way? And really, you'll get to a point once you start using these ADTs to where there is an imperative way to do it, but it's completely removed from the way that you would think about solving the same problem, like using algebraic data types, right? Like even more so when you're using Ramda and stuff like that, you're still kind of close to it. But when you start like really getting used to algebraic data types, it's not really about do this, do this, do this, like you would even do with Ramda, with pipes and things like that. It's more about, I have this structure, or I have this behavior, and I have all of these different structures that could represent that. So instead of doing this, doing this, doing this, typically you're putting together some sort of type or an interaction between types and folding down on something, or it's just a different approach. So the stuff that we're going to be doing for this session and maybe a couple more sessions, we will have the advantage of being able to provide a kind of a one-to-one imperative versus declarative implementation. So we're just going to take advantage of that. And then I'll try whenever it makes sense to do so going forward to always provide, hey, what this might look like imperatively versus how we would write it or approach the situation declaratively. But be warned, we're going to get to a point where it's just not going to make sense anymore. So we're going to kind of diverge from that path, if that makes sense. So without further ado, looks like we have some people here. I will start doing a little bit of coding. So let's start with predicates. So a real common predicate that, or something that we could use, provides a less than or greater than. We're checking a value to see if it's less than or greater than something. So let's just do a quick, is this less than something else? Okay. So let's start up here. Look at that. We got a little mouse going on. And we'll just create the first imperative function that goes from a number to a Boolean. Now, it could be any order, but we're going to set this up to be just using numbers. We're not going to get so much into like postsets or presets or pre-orders like right now. We will probably later on start getting into that, the algebraic part of that. So let's just make an imperative here. And this is basically going to take an x. And then we'll take that x. We could call it number or whatever, but typically I like to represent my data as x. Oh, heck yeah. Ooh, I don't know how to pronounce your name. I don't know what the accent means over the E. Gosh, I'm going to ruin this. Berries? Nope, see, it's wrong. Well, thank you for looking forward, Guy Lemon. That's a really great name. Hey, anytime. Okay, so what we want to do is real simply, this is a predicate function. It's something that you would see like inside of an if. It's where we're taking some value, doing some comparison, and returning a Boolean to that. So if we were to go here and if we want to see if, 23 is less than, well, I'm just logging 23. That's adorable. Hold on. So we'll call imperative. Oops. We'll call imperative. And we see that that's false. Now, if we come to here, we'll get a 9. We see that that's true because 9 is, in fact, less than 10. So, mate. Ha, heck yeah, mate. And then, of course, undefined. We won't get into undefined and things like that. But if we were to take 100 or let's say negative 100, we know that that is less than 10. So these are real simple. These are just predicate functions. In this case, we're taking something from a number to a Boolean. Now, one of the ways that we could represent this, and we'll just bring in less than from Ramda, require, and then we'll just bring in Ramda. All right. Now, the thing that's kind of funny about this version of this is how we would do it, This is how we would do it with a Ramda function. One of the things that you'll notice about some of these functions in Ramda is they're not all point free. So for instance, this less than isn't point free. And the reason why is the thing that we're going to be comparing to, like what our x is, remember that this is the actual data. If we look at their less than, let's do less than. If we look at their less than, notice that it's if the first argument is less than the second. So they're doing the comparison. The data is here, not here like we would expect it to be in a point-free function. So it's really hard to compose these in. You find yourself having to flip them, do things like that to actually get them in your compositions. But that's okay. So what we'll do is we'll bring in the flip from Crocks because it allows you to do, how would you say, partial application, like during the application of the flip. Just makes it easier for doing point-free flows. So just to show you what I mean, we'll do const declarative and declarative. This is basically going to be less than, and we'll say 10, right? So now if we go to declarative, see how that's false? Because we want to apply, like, we want to always make this be a thing that is less than, oh, that's the one thing I don't like about, hold on. And let's go 23. There we go. Sorry about that. All right, so one of the things we'll notice here is when we call it, this is saying that 23 is less than 10, and we know that's not the case. And that's because this isn't flipped. The data should be here, and the actual thing that you're comparing the relation to should be the first thing for it to be a point-free function, right? So we can fix that super duper easy. We'll just bring in flip here, and then we'll flip that, replace this, and replace that. So now what this does is, because of the way the currying and all that works in crocks, is it's going to take in this function, flip the arguments, and then give back and then apply 10 to that. So we basically are making this the comparative thing, right? So now if we go and run it, we see that it's true. 10 is not less than, but if we do 9, it is, and 100, right? So this is just an example of like when you have to, like when you should pay attention to, does the data come first? Or does the data come last? And if it is, you might want to reach for flip. And there's also cases where the data that they're considering the data isn't the data itself. So you'll have to, you need, hold on, that made no gosh darn sense. So a lot of times functions, what they consider the data, like what is the least stable of the arguments, may not be the case for your flow. So you'll use flip from last time a lot. Hey kitten, you got to get down. You can't be up here. You're moving the mic. I'm so sorry. Sorry about that. Yeah. So let us, yeah. So this is the example, sorry, got a little off track. This is an example of a predicate function. And again, these are the things you would see like in an if or things like that. So this would be like this, right? Anything that you have inside of an if statement, and anything like, say I were to do an and, you know, if we want to give a range, x is greater than 0, right? So now this will give me a number 1 from 9 or whatever. Everything inside of here is what the predicate is. So what we're doing here is just building out a function that we could replace like this, right? Declarative, and pass in whatever our x is and, you know, do something with it. So that's all this is. Just a little, that's all a predicate function for the most part. How we use them come into play. So this is one example of one. Another example of one is maybe we want to do checking to see if something is an array, right? So if we can take in any type A, we want to check to see if this type A is actually an array. So there's a couple ways to do this. If we're using ES6, we could do something like this, where we're all like array dot is array. Oops, that was cute. Array dot is array, and we'll apply x. Now I know I could make this point free, but this is more of the imperative way. There's other reasons why we don't want this point free, because it looks bad on the example for doing negation that's going to be coming up later, things like that. So we won't do that. We're just going to take in that function and apply it. So now if we look here at imperative and say we pass in an array, so that'll come back true. If we pass in an object, that'll come back false. And if we pass in, you know, a value of true, true comes back false because it's not an array. Hey, it's okay. You're not late. We're just really getting rolling. Starting to get my stride. Okay. Now, to implement something like this declaratively, we have, at least in crocks, a function, predicate function is array. So we don't really need to do anything if we're using that. I wonder if they have an isArray. I don't know if they ship with predicates, but we provide an isArray in crocks. Yeah. So all we really need to do is just bring that in, and we pretty much have that function for us. It's already implemented. So this then becomes isArray, and yeah, that's pretty much all we need to do for that. And actually, let's leave flip in. We're going to need that. All right, so if we jump down here and then do the declarative, we see that true is not an array, but if we pass an array in, we get that. If it's an object, we get that, right? We get false because it is not an array. Again, this is just another example of a predicate. We have many different types of them, but this is one example of a predicate. Also, if you do not have EF6, if you have to do something inside of, how would you say, if you need to do something inside of ES5, like what is that, IE or whatever, for one reason or another, maybe you're supporting some portal or something like that, then I'll show you a way that you can determine if it is an array. And it'll work inside of iframes, like, you can't really do is instance of array because it might be an array from a different iframe. Anyway, there's instance of can be kind of a real bummer. So I'll just show a quick way of doing this. And all we do is just take object, and off the prototype, we just grab prototype. The toString function, and then we want to call this with applying X, right? So if you look here, see how we get object. If I were to put in a new date, let's just do that. I get date over on the right side. And if I were to actually put in an array here, we get back object.array. So this will always, no matter what, instead of instance of, you can do this to actually get a kind of what the constructor is over on the right side. So now all we really need to do is say, is this equal to object array? And if it is, then we return true. Otherwise, if it's not, we return false. All right, so that's how you would do it in ES5. This is a good, safe way of taking care of this. I don't know if you've ever done any iframe stuff or things like that, but if you're checking instance of, that was something we used to do a long time back, and you're doing stuff inside of arrays, the array that you might get passed into you may not be an instance of the array that is implemented inside of that iframes window. So just so you're aware, this is a good solution for instance of. All right, anyway, I like to sidetrack a little bit, and we'll say that that was our sidetracking, right? So let's go ahead and we'll put this back to array.isArray. And this is why I kind of wanted to keep it the way that it was. Because what if we want to grab everything but arrays? So say I have this, and I put in an object on imperative. See, that's true because it's not an array, right? We've negated that array. So if we do put an actual array in here, of course, since that was true, it gets negated to false. And, this is just simple negation. This is the same stuff you would do inside of an if when you say not whatever, right? When you do this declaratively, though, and we're starting to get into some of the differences between crocks and Ramda. So they have a not, but their not actually takes a value. Notice, and it takes a value, and from there it will actually do the negation of that value. They have this well, hold on, let me get to here. Not helpers, but logic functions. So R naught actually takes either a predicate function or a pred data type. We'll get into that some other time for what that is. But it'll take either one of these and then return you a new predicate. And they have this same function, but they call it complement. So if we look at complement here, notice it does the same sort of thing. It takes an actual function and then complements it. But we don't really have functions in crocks that take values. Most of the functions actually take functions. So yeah. So that's one difference. If you're used to using array, if you're used to using Lambda, this might look a little funny to you because this would actually be the complement. So what we'll do here is just to make this an actual not, that's all we really have to do. So we pass this a predicate, and what it's going to do is take the value that it receives and then apply it to the inner predicate, and then it's going to negate it for us. So this still gives us back another function. So we were able, or another predicate. So I was able to take one predicate, pass it to this, and get another predicate back, which is the implementation of, whatever that flow is. So if we look back and check declarative out, we get back the same thing. See, it's false, but if I were to pass in undefined, that's true because undefined is not an array. If I were to pass in null, that's also true. A number of 23 is true, and the same thing goes for this. So it's the same sort of thing. The only difference is instead of spelling it out this way, we spell it out by building functions or building predicates from other predicates. That's one of the main differences between the imperative and declarative approach, right? And again, these are the same things that are going to be used inside of different if statements and whatnot. All right, so we can also look at what negation looks like for the less than that we made. So remember that less than that we made earlier? What we'll do here is, so if the opposite of x is less than 10, the opposite of that, and this needs to go back to number, and this needs to go back to number. Oops. There we go. So the difference between that, or what we would need for the opposite of this, is to actually be greater than or equal to, right? So that'll be our greater than or equal to 10. And if we look here, this should be true, but then anything below it, because remember, this is the negation of less than, anything below it should actually come back as false because it's just negation on that. So this is not, the other thing we could have done, just to make it look like the other one, is we could have done this, and this matches more what we're doing declaratively. So just by appending the not to it and taking the expression, that's another way of doing that. Not taking a function, isn't that hindering the use in composition? Well, sort of. But there are great uses for this. Like I have times where I need to apply things to it. So, and they do provide, Lambda does provide a complement to that called complement that will take the function and then behave the way that you expect it to. So if anything, they provide more options by having it this way. I was just more pointing out one of the differences. So the not in here is a different not. It's more like their complement. So it's just, I figured, you have, or there is Lambda out there that has all of that stuff to it. So if people wanted something that needed to apply, like that wasn't the function, then they could use the Lambda version. But the reason why I made my own version here is because we use this pred data type. So all of the functions that are logic here use the different data types, right? Or you can use either a predicate function or a pred. A pred is basically, how would you say? It's a monoidal contravariant functor. It basically takes, gives you a way to combine predicate functions, but in a data type instead of with functions. We'll get to those definitely once we start talking about ADTs and things like that. So again, for this is just the declarative approach of this is the same thing. We're just going to wrap the not there, and then we do less than 10. And if we look down at declarative, we get the same thing. So that's true, imperative, true, declarative, and we'll make this 9, which should be false. So as you see, there is a kind of a similar, or how would you say? They kind of match one-to-one. We're actually wrapping this not. We got the not here and just knotting the expression. It's the same sort of thing, except now I can compose and build on these. Whereas here, if I were to want to add something to this, I'd have to go into the if statement and change it about, or do it manually. And it's not reusable. We could still make it reusable, but you typically don't do that with imperative approaches, typically. Okay. So now we have, we'll totally do the pred stuff for real. So the next thing, now that we have this not and the little flippity doodah and all that, this pretty much is how you would get it to work with negation. I could take any phrase or any predicate, and remember, this also returns a predicate. So I could even not this not by just passing it to another not. And anyway, it allows you to build up these flows by doing it declaratively this way, or build up these predicates starting from real simple predicates and then adding your business logic to it by using these logic functions. Okay, I think I'm beating a dead horse there. We will continue on. All right, so now that we have not under the way, there is another operation that you might have seen living inside of if statements. Oh, how and why it's a pred is a semigroup. It's a semigroup because we can do it as an and, right? So it's this and that and that. So when I put those together and actually, how would you say, concat them together, they concat under conjunction. But yeah, we'll totally get into pred. It's one of my favorite types. There's a whole article on it. If you're curious, I stole this type. Well, I stole it from Dr. Boolean, who stole it from Haskell. He's just smarter because he gets it from the source and I get it from the secondhand source. But he did a whole article on it and I liked it so much that I added the type. But I give him credit here totally because everyone needs the credit that they deserve. Anyway, that is a cool little thing. Okay, so we have declarative, we have imperative, burp, 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 burp. I like the pred type. Okay, so now we have part 1, object number. Okay, so one of the other things that we might run into, and let's just, we could do the whole is object thing and do it like we did inside of, how would you say, like we did, with the object of object, because we really want something that is POJO, right? Like we want a plain old JavaScript object. That's what this is object is. This will not return true if it's actually like, say, a date. I don't think so. Let's see. Let's see. Is object. I think that we changed something. Sorry, I might be filing a bug report right now. Okay, good. Yeah. So this is object is not going to work for something that is constructed. It's only for what's called a POJO or a plain old JavaScript object. Okay, another tangent. I used to be a outside plant engineer for the phone company. What that means is like I designed jobs that put up telephone poles and silly things like that. I did road projects. But anyway, we had back in the day when I was doing this, if someone had a normal landline, we called the POTS service, POTS. And what that stood for was plain old telephone service. So they were POTS lines. Anyway, I was really happy whenever people started adopting the use of Pojo because it's just, yeah, it should be as Pojo, but then you got to explain Pojo because remember, we're not really typically creating objects like with constructors and things like that. So there's more value in making sure that it's an actual data type, or not a data type, but just a normal Pojo, basically. Anyway. Sorry, I get so distracted. I shouldn't go off on these tangents. So what we want to do is we'll look at and, basically. That's what we're doing now. So what if, and let's just say is object X. So you might see these, this kind of makes appearances inside of if statements, something along those lines. And say we want to check to see if there is a key that has a certain value of, we'll say 100, right? So this is going to take any type A, and this will end up taking any type A. And it's going to give back a Boolean. So what this means is if I have imperative, and let's say I put in true. Okay, true is not an object, so it's going to fail, and it's going to fail before it gets to that. What if I put in undefined? Undefined is going to fail before we try to access that X. And if I have a null, and just to show you undefined, right? So that's all going to do that. If we have an array that's 1, 2, that's going to fail. The only thing that's going to pass on this, df this, is going to be if we have an object and it has a key of that is 100. So if this is actually B, that's going to be false. If this is 10, it's going to be false, right? So this is basically a simple conjunction, or we basically just do this and. So if we have this and, yeah, I think I've demonstrated enough. I don't think I need to go on and on and on about it. So how we would get this to work is we actually have, believe it or not, an and function. And again, another difference here that I want to state. It's not that it's a bad thing. It's just another difference. You might be if you're used to Ramda. Notice and also takes values and not functions. So same sort of thing that's going on here. We differ there. So I hope that doesn't cause any confusion or anything like that if you end up using some of the crocks ones. Okay, so this is actually kind of easy. We'll do an and all we do is object. And that handles the left portion of it. And this does work. The thing on the left will be executed first, and the thing on the right will be checked second. So if the first one fails, it's just going to bail right the heck out of there. That way you avoid errors and things like that, which is why you would use an and or something along these lines. So we have another predicate function, and I think they have it too. Predicates. All right, so we have one called prop equal. And this will basically take a string or an integer, takes some A, then takes an object, and then returns true. A can be anything. It doesn't need to be an object. It could be an array. It could be whatever. So this is exactly what we want to do, or exactly what we need. And we've already verified that it's an object. So really, we don't need this and here. And I'll show you why. I just realized that now. What a horrible example. Because prop equals will take care of that for us. So we need to bring this in, and that comes at the end of this. Prop equals. Why is that not? Oh, because that's a Q. All right, stand by. Okay. So now we want to check to see if there is a prop A and if it equals 100. So if we go back here and do declarative, we see that that's true. It matches the same thing. And just to put in like null and all the other stuff, see, that'll be false, undefined. If we put in a new date, and I don't think we showed this with imperative, it would be the same thing, but it doesn't error or do anything like that. So this same sort of thing, how you would have this inside of your if statement, this is how you would actually represent this inside of, or doing a more declarative approach. So I can now take this, and this can now even be added to another and. If I wanted to have another and, I can put this, because this is just, again, a predicate function. And these logic functions take predicate functions. So I just can keep piling them on each other, on each other. And it's super duper fun. Okay, so now this is where we'll start to run. This is where using helpers and things like that may be helpful. So say we want to check to see, and because of the way reference and value works, say we wanted to see if the value or the object inside of there actually contained an array, a singleton array with a value of 100. Say that's something that we needed to check. So this is where the value of using libraries come into play, as opposed to, and you can use these, we could use this imperatively as well. I just want to show you something just so you're aware that this is a behavior, and a lot of these functions take care of this, right? So if I were to come into here and I were to set this up like that and get rid of this nonsense, and say I were to set up A with 100 there. See, by running it declaratively, that's going to come back true. When I go and when I run it through that function, it has nothing to do with it being declarative or anything like that. I don't want to mislead you there. But when I use this prop equals function, more importantly, it comes back true. Oops. There we go. But if I go to imperative, that comes back false. And the reason why is these are two different instances. So this is an instance. This is where the reference comes into play. We're actually comparing references to see if it's the exact same object. So if you use the prop equals from Ramda, or you use the prop equals from actual crocks, it does by value comparison for equality. So it's actually going to look deep into objects and everything else, and it's going to make sure that, they're the same. Yeah, that their values equal the same thing. Okay, so that's more of an aside. That has nothing to do with imperative versus declarative or anything like that, right? Okay, so now we have our actual OR. We're going to get, what is our time like? So we've been at this. Okay, cool. This might be really, really great. Might be really, really bad. But I think we're actually going to end on time today, even with my silly little derailments. So the next thing we can do, and the other thing you might run into, is doing disjunction, right? So say we want to see if something is, how would you say, is array, or is an object, right? Uh-oh. I didn't copy one of my examples over. Going to have to do it from memory. Show the prop equals without the is object. Oh, yeah. Thank you. I totally spaced that. What a silly little goose I was. All right. So you can also do the prop equal. Let's just make this declarative. And here we'll just do prop equals. So you'll see that this still is true. And we didn't need to check to see if it was an object. Well, I mean there anyway. If I were to put in null, oops, d2 this, and like if I were to put in null, still comes back false and still behaves the same exact way that it did before. And that's because we check to see if it's an actual object before we get on there. And let's do like new date. Ooh, I'm wondering, let's see here. Oh, I shouldn't be exploring with stuff. What is a date JavaScript functions methods? That is on that parse. Those don't look like methods. All right, so get full year. Let's I'm curious about something. I shouldn't be doing this, but I'm gonna do it anyway. And let's say, oh, this is prop equals though. I don't have the function. All right, I'll play around with this later. I'm curious what that check can do. Okay. All right. So we have that. What were we on? Oh, yeah. We're doing is object, is array, that sort of thing. So how we would do this is with a, we would actually use or, is object, is array. And that gets us the same sort of thing. So if I do imperative and we do an array, that's going to come back true. If I do that, it's going to come back true. But if I pass in null or undefined, it's going to be false. That's false. The number 23 is false. And yeah, it basically checks to see if it's an object or is an array. And you can use, a lot of times disjunctions can be used to create unions on types. So maybe I have a function or something that does work with an object and an array. So instead of thinking that as two separate types, think of checking those two types and being able to accept both of them. Kind of think of that as creating a brand new type that could either be this or that. Anyway, that's another case for using those. Okay, so we have that. Oh. Okay. So this is basically what you would do in OR with, right? So now to kind of give an example of like building these out to be, how would you say, very complex, we can actually create something here, and we're going to call this has length. And yeah, so let's do has prop. And this will be a length. Okay. And it's not that it has a length, but it's going to be, it means that it has a property of length. So let's say has length prop, just so we understand what's going on there, right? So then we'll come in here and do ICANN has prop. Ooh. Yeah. So what we want to create, I probably should have did the imperative thing first, is we want to say is object now, and there's a couple ways we can think of this. So we can think of it this way, to where Okay. So we can think of it this way. Say we are checking to see if it's an object, and if it is an object, it has an actual length, or it's an actual array, which we know that we have a length for. There's another way of doing this, but many other ways that are much better, like just checking to see if it has a length. But, guess what else has a length? A function. So we could probably say, oh, you know what, maybe not a function, but has a length. But we're going to go this route because it's even more complicated and way more contrived. So it'll show some fun ways of putting things like this together. So if we go here and give this a save, we see that this is false. If we go here and let's say pass in an object with a length of 2, that comes back true. If it's an array, say it's not length, but say it's a plank. See, that's false because it doesn't actually have that value. It doesn't have a thing of length there. But if we have a length, if we have a length, and even if it's null, it doesn't matter because we're checking to see if it is that. We could, let's see, we have length, we have that. Okay. Yep. So that comes back true. And then also v x, and we'll do this. That comes back true. And both of them have a length. So we made sure that it was an object and it was a length. So we could do this way. Now that we have this little, this is also a predicate that has length prop. Takes some sort of a. It doesn't need to be an object, but it takes some sort of a and gives back a Boolean. So again, notice it's just a predicate. So for our declarative, what we want to do is actually set up an or, and then we could set up an and inside of here that is object and has length prop, and then our or is array. What are you doing there, buddy? See how it just lays out? And it's pretty much the same sort of thing going on there. Except it's just set up in functions, and we get a function back by applying different functions and things along those lines. Strings are the same way. I mean, strings, you're right, they have a length as well. So we want to not have a string. Good call, good call. But so this, we could exclude strings, we could exclude that. But a lot of times it's a lot easier to make an acceptance list than a denial list because you could end up denying things. For instance, I, as the total noob that I am, totally forgot about strings having a length, right? So if I were to set up a denial list or like negate things and say, don't have this, don't have that, I could end up missing things. So you'll typically want to go, it's less and easier to handle for writing predicates like this, especially for type checking or checking properties about things. It's a lot easier to go the route of acceptance as opposed to denial. But yeah, so great. See, I forget all kinds of things. How ridiculous I am. All right, so now if we look at the declarative, we get back true. If I pass in an object, that's false. But if I pass in an object with length, and we'll make that 45, that comes back as true. Same sort of thing. You just put it all together. Yeah. So another way we could do this, because I wanted to get into De Morgan's laws and wanted to show like how to do different things with De Morgan's. But I might leave that either as maybe I'll do a follow-up or something, like a 20-minute one. But I think we're going to run out of time to go through the De Morgan's laws. Because I also want to show how to create like ifs and elses and do other things along those lines. What is the best way to do this? So, because we really only have about another 10 minutes. So I think what I'm going to do is we'll talk about if else and then we'll implement an applies logic. How would you say logic combinator? Yeah. And then next week, we're going to look at other ways of doing like it. We'll go over De Morgan's laws, and we'll also do, how would you say? We'll look at like unless and when and like other ways. Okay, perfect. We got a plan. Let's get cooking. All right. So the other way that we could move this around a little bit is maybe we want to look to see if, I don't know. We could do is object, is array, keep our disjunction there. And then even though we know that we're always going to have that, let's put in one here, get rid of this. Oops, go to the end, silly boy. And this will probably say, hey. Oh, interesting, it didn't. Oops. All right, so now if we go to imperative, hopefully this gets us the same thing. That becomes true. If I call this plank, it's false. This will become true because it has the length, things like that, right? So all this is just moving stuff around. So we just take the or, and we'll pop this out and pop that there. And I think we're good. Yep. So all that is we just move it around, see how it matches what's going on there, and then we're actually checking the length. So you can get these to match one-to-one what's going on there, right? So now if we jump down here and then run the declarative bits, that of course is false. If we put in a length of 34, doesn't really matter. We'll get that back. 4 doesn't matter. Plank, of course, will be false, and always this will return true as well. So I hope that makes sense. Are there any questions or anything? Because these are pretty much the combinator things that we use for logic. We have and, not, and or. The other three, when, unless, and if else, are actually places that will use it. Notice they also take a predicate or a pred. So you can pass out a pred or a predicate to anything that takes a predicate function. So for instance, once we start getting into ADTs, we're going to look at like a maybe type. And of course, that's a safe, right? So that has a safe function. And that takes a predicate. So if there's anything that actually takes a predicate, filter takes a predicate. So filter can take a pred or a predicate function. All of the predicate accepting functions will take both throughout the entire library. And you'll see the power of that once we start getting into ADTs. A lot of this putting together and building these complicated things, because it probably doesn't look complicated compared to this, but we can actually capture a lot of this inside of a type. Especially with it flipped. That's kind of why I'm trying to get you to think to move your ands to the outside. And the De Morgan's laws and other things would have helped with that. But we'll rediscuss that or rehash what I was trying to show here by moving the and out next episode for sure. Okay. So we have that. So let's just... We run into cases. We looked at all of these silly little... functions and like how to build these predicates out, but we never really showed like how they could be used, right? So if we look at how they're used in other places, more imperative things, let's do imperative, and then here we'll take value. A lot of times this is going to be inside of a if else, a when, or a where. like that sort of thing. A while loop, not a where. You're going to, usually when you're doing things imperatively, you're going to, these will be the predicate clause inside of a keyword that takes a predicate. So we kind of have the same thing with if else, right? So let's just we'll just make this super simple. We're not going to get too crazy with building of the predicates and things like that. But that's okay. This is very introductory. We can move that stuff, to next week's episode. But we'll just do the simple less than that we did before. So we'll just do less than 10, right? We've done this before. We know how to do that. So we would have some sort of predicate that checks something. And of course, remember, we got to use let a lot. So we're going to do a result, and we'll set that at least to null. It's better than it being undefined. So we have this result set to null. If the value is 10, let's go ahead and just add 10 to the value. And that's going to be our result. Okay, now this is completely contrived, but I bet you if you look in your code, you have a lot of code like this with the let that does that, with a return result. It seems contrived, but this pattern actually comes up a lot. So let's say what we're really doing here is if it is greater than 10, or 10 or greater, then let's go ahead and subtract 10 from it. Otherwise, let's go ahead and increment it. Right? So this is pretty simple. We don't need this silly little guy anymore. And declarative is going to be something different. Okay, so let's look at the imperative. We're not checking to see if it's a number. We're not checking that. We probably should, but I don't want to cloud the message here, right? Typically, you're probably going to want to check to see if it is an actual number before you start doing the comparison. That's what you would do in a real life app. But I don't want to cloud what's going on here, right? See, because I'm going to do it anyway. So we can just say is number, why are you doing this, Ian? Value, right? So we would check that is, oh, this is out of order. And number, why do you even do this? All right, so I'm gonna do it anyway. Okay, so we can basically check to see if it's a number. Oh, but that's not what we want. Goodness gracious. Okay, that's why I didn't do it. We actually want if is number. We're going to save that for maybes. That's a good case for maybes. See, I'm glad. I'm glad I caught myself because that was going to be a rabbit hole. Not really too much of a rabbit hole, but I'd have to explain a lot of things. So, woo! Glad I stopped myself. Okay. I stopped myself as soon as I saw it was going to be a problem. I should have stopped myself beforehand. All right, so if we take imperative and let's say we pass in 40, notice we get back 30. But if we pass in 9... actually, let's make this easier. If we pass in 1, we're going to get 11 back, right? Real simple. So if something comes in, we check that value to see if it matches some sort of bit that we need. If it is good, then we want to, or if it passes, we want to add 10 to it. So if it's less than 10. Otherwise, we want to subtract 10 to it. But notice how there's two different paths of execution here. And again, this might be, well, we'll get to that in a moment. So how we can represent this with Ramda or crocks, and again, there's a difference here. So if we look at if-else here, one of the major differences, number one, other than they take a pred, is they take a verdict, I can never say that right, function. It can be up to n parameters, and then it goes from n to n to n. Notice how they have the dot, dot, dot here. All functions here are unary. So if you notice, you take an a to a b, you take an a to a b, a to a b. I wonder if that should be Boolean. I think there was a reason why. Oh, because I course. Never mind. So yeah. This is going to give back. This should actually be Boolean, though. I need to fix that. Let me make a note. Oh, crocks. Fix. If else. Siggy. Sorry about that. I'll forget to do that if I don't do it. All right. So, yeah, I need to fix that signature. But the difference here is they use n-ary and we are unary. So we'll only take one. Only take one thing in. So that's the difference. If you're used to not doing that, then you might want to go with the if-else. You can switch back and forth. It doesn't matter. Unless you're using preds. The other difference is you can take a pred in as well. Okay, so now that we have the declarative, how we can represent this is we just do if else, and I need to bring that in. One of the things we'll notice, I'm sorry, I probably should have went over what the signature was, is this takes a function. Oh, no, that is right. I'm so silly. This is good. I'm going to cross that out. This is good. So basically, this is going to take a predicate function, and then if that's true, it's going to take another it's going to take two functions after that. If the predicate is true, it's going to run the function on the left, or the second function you passed, first function you passed it. And if it fails, it's going to run the third function, or the third argument, but the second function you passed to it. Then it's going to take an A, check the A against the predicate, and pass it to each one of these, returning the result. I hope that makes sense. If not, I mean, if you use Ramda, you probably used if-else a few times. But for any people that may or may not have used it before, check it out. So what we want to do is do our flip, and we want to flip because we're using the Ramda less than. Check the 10. That's going to be our predicate function. So if this is good, we're going to add 10, and we're going to bring in the add here from Ramda. And if it's false, if it's not less than, we want to add negative 10. And we need to bring in the if else. If goes here. Okay, so now if we just jump down to declarative, we see that we get back the same result as we did with the imperative. Same thing, but now if we're over 10, notice how we go back to 1, declarative. Still the same thing, goes down to 1. So that's basically, this captures this flow. And any of these predicates, they could be, these predicates here, they could be as complex because we can build them all out. So we could say const pred, you know, if it has a length, if it does this and that or that, and it passes that, then you can have just your branch here that goes to and, or you could have the, the truthy path, and you can have a falsy path. So, yeah. If I want the opposite behavior, again, it's just doing the negation on here, just like we would normally. I could just do the negation, and now it does the exact opposite. So if I do 1, it's going to give me negative 9. See what I mean? So we are at our stopping time. I'm so sorry. But next week, we're going to pick off where we left off here. I'm going to try to get these down to an hour. I've been looking at fall-off rates and things like that. And it looks like about 45 minutes is pretty good. I have people watching up to 45 minutes around. There are some drop-offs, but and it looks like some people may come back and pick up later. So I think an hour is actually pretty good. So I'm going to try to keep these at an hour of content. So this is great because it'll give us a wonderful place to pick up next time. So the final goal of all of this is we're going to, well, not the final goal, but we're going to see how we can use these functions. No, this is not Kitty. This is I don't do this on a Linux box because the camera is crappy. This is just iTerm. Yeah. So this isn't Kitty. And the KITTY, no, that's on my Linux box, my Arch box. I needed it for my Xmonad instance. I needed something lightweight that did ligature and things like that. This is just normal iTerm on a Mac, you know. I know Kitty runs on the browser, but I don't know. Or runs on a Mac. I might try it out. But yeah. So we're going to be doing next week, we're going to pick up where we left off here. We're going to look at when and unless, which are different ways, so are really neat things that you can do. And we're going to look at the implies. So if you look at logical implication, let's say logical implies. That's funny. I searched for... Anyway, so we're going to be implementing this, which is basically an implies. So if this predicate passes, this will basically make something that takes two predicate functions, just like or and and. And if this passes, then it might imply something else over here. It implies that that's true. So if all of these are true, then that's true. If this is true, then that's false. And then, ooh, is that right? I don't think that's right. Yeah, that one wasn't right. This one's right. Because if this fails, these always need to be true. So this is wrong wherever this came from. Quatra. This is actually right, because if it's false, then we know that it's true because it doesn't match the implication. Anyway, sorry. Wow, talk about bad information. But see, this is also doing a... Anyway, yeah. So we'll be looking at implication and building other stuff. So that's all I got for today. Thanks so much for stopping by. I hope this was helpful for you. Subscribe if you want. I don't care. Like it. Do whatever the crap you're supposed to do with this. But yeah, I will see you next week, and I hope you have a wonderful day.